On the relativity of time, a philosophical comment. Except for the transcending experience of God, I think Einstein was right in writing that time is relative. Within any given criterion of cosmology, there may be a prevailing local thermodynamic process against which subjective time could be compared. However, spatial limitations may be as relative as time. There always being a larger or smaller criterion of being, so an absolute time must remain within the Creator as an atemporal continuum of being. If general and special relativity are correct, I believe it is easy to infer that time is a function of the relationship of mass energy to thermodynamic process. Time is experienced within a field. There is no absolute independent timeline within a given physical process, for space-time are unary aspects of the field in motion within that field is subject to relative experience of the field. A given point particle mass traveling within a given field of the expanding universe keeps or quits its local assimilation with mass and accelerates its mass structure through a field comprising differing and new relationships to other fields. One does not experience all of the fields of the universe as a single unified field through which one journeys. One is also a part of that unified field. The inertial frame of reference comprising oneself or point of mass energy experiences time and change mentally as a correlation. That is a cognitive interpretation of the local relationships of mass energy states of affairs. Instead of gravity or gravitons, fundamental quanta may be zero-dimensional units of time dragging their heels seeking to attach to space that does not exist. Like SpaghettiOs without a bowl or gravitational field, they may move toward one another or away or even interact with an unknown kind of low-key charge in the underlying empty space containing the universe itself. Well, it's food for thought. Why or how should time originate? If the universe started as a singularity, should time be all too lumpy because of symmetry breaking of the Higgs field and an unequal distribution of mass for inflation that made mass clump up with anisotropy? If time were an independent thing for itself, irrespective of mass in the universe and its thermodynamic progress, should it not then be smoothly formed, or graduated perhaps like waves building in strength, a scalar field with intensity increasing with larger size, or perhaps rate of change of time increasing with increasing scale? Alternatively, time may have issued with a quanta emerging from the singularity like SpaghettiO sections of little strings or zero-dimensional membranes. Time like zero-dimensional SpaghettiOs flowing under intense force from the Big Bang at zero initial condition, steady state of non-temporal rest. It's a tough concept to spoon up. Innovation is a mother of invention, though. If time can be associated with discrete units cut like little bits of watermelon from a giant blue ribbon watermelon at an eternal county fair before the Big Bang, it may clump along like matter and have an entirely relativistic character viewed from within a field of time. I have thought about time quanta instead of just mass energy quanta that exist in the time field. Just because complexity following thermodynamic lines occurs in a given order that can be explained phenomenally regarding the rules of attachment or order of force characteristics of the quanta. Anyway, here is something about time quanta. I like the idea of a universe of discrete time quanta that, when acting together, seem to make time appear to exist in a given direction. Time reduces to near infinities at the event horizon of black holes of concentrated mass. Without change and with time brought together, there is comparatively little experience of a change or progress of time. So, there may not actually be gravitons then. Why should there be a large particle crossing large empty space to link mass and energy? Perhaps it is a concatenated local effect and diminishes with distances because the mass thins out in empty space and gravity needs to bond its force through existing particles, rather like waves in the ocean. Gravity could be something entirely else, though, a kind of apparent force thought of as gravity, yet actually entirely a local and short-range force. Einstein would be nearly entirely right in this context. Space would seem to be bent like a rubber sheet depressed with mass upon it, drawing another mass to its slippery slope. Farther away, of course, the space-time smooths out, and the force of attraction diminishes toward the reference mass. The difference between apparent gravitational force through particles of attraction and Einstein's logical warping of space-time because of mass, for many of us non-scientists, has presented a two-part approach to understanding what gravity is. Since they seem respectively somewhat inconsistent, I will provide another way of viewing gravity based not too much upon either. Gravity might be an apparent phenomenon concatenated at the mass level that disappears with an explanation of what is really occurring. Mass-energy particles may be associated with the time dimension in proportion to their comparative scale. Gravity particles or waves may not exist at all. The time dimension is short-range and in relation to the scale of each unit of mass energy. The initial impetus of the inflation and Big Bang era imparted a tremendous force to detach the time stability of the basic quanta. As the inertia of the quanta was spent, time was created outwardly with space, and the quanta, though implicitly seeking to bond with a particle-spatial relation, perhaps had far too little time content individually to accomplish the reversal of space-time in themselves. This may seem something like trading a graviton for a timit-i-ton, and perhaps it is, yet each basic quantum must exist with one unit of time for itself as a being. The assertion of time concatenated outward in an expansion of time and space may be a way to account for it and number relativistic and quantum mechanical phenomena concurrently. The acceleration of observed expansion speed of the universe may not be a consequence of dark energy or mass, but could instead result from individual timit-i-tons orienting themselves toward a non-centralized direction in their effort to attach to space. It is interesting to conjecture about a singularity of time and space that becomes subdivisible into fractions of time-space quanta subject to macro-thermodynamic effects. It is also intriguing to consider a quantum mechanical computer-like universe that can generate one-off instantaneous universes of space-time in infinite number as branching devices to become consistent with observation. I should remark that God may have far more complexity in quantum mechanical and macro-cosmological potential than might be thought of by humans. The attachment of time unit quanta to space may be a feature of quantum superposition with entangled, larger space-time energy structures with a detachment from time context of space itself. Space could be timeless without content, or mass energy, of course, and would be a shortcut for which time quanta may associate. One may consider such a topology of time with a variety of hypothetical features, of course, and these are some of those that I have had today. If non-dimensional time quanta exist that emerge with attributes comparable to spatial dimensions, the acceleration of the universe could be an effect of time quanta seeking to attach to their own source that was dispersed at the proximal creation event of universal inflation. Such initial expansive force could only slow gradually and away from the cosmic origin of non-dimensional time, the time quanta pull outwardly with equal statistical probability as inwardly.